I'm going to describe how to get the highest bit set in a number with no shifting in a loop or whatever. At some point, if I explain enough, I'll be able to explain it better. Math sucks, but you don't need math to do math. You just need a logic. So like, I'm writing a JavaScript engine, whatever. I have to like finish writing it. I have to finish writing shader, and then finish getting on Linux from Windows. And I don't know, yeah. So first off, to get like the highest bit number, where's if I just did this on? I'll just type it up again. I think this is it. Alright, so to get the highest bit set in a number without any math, just logic and the position of a number within a column and like linearly mapping it to the index of the bit position that belongs in. What? I don't know, whatever. Basically, first you got a bit smudge. Well, I don't know, that's but I'll explain it better. I drink some water. So dry.
Describe bit smudge in relation to bit twiddling. In the context of bit twiddling, a bit smudge refers to a pattern where, after manipulating a bit in a number, usually setting the highest set bit, all lower bits are also set to 1. It's a result of a common bit manipulation trick to fill in bits below the most significant set bit.
I want to see your mouse bits. It's not that funny.
Blue textbook. Explanation: imagine you have a binary number, and you want to smudge or fill all bits below the highest set bit to 1. This is often used in algorithms to normalize or prepare values for further bit manipulation. Example: C-like code. Here's a typical bit smudge operation using bit twiddling. After these operations, V becomes this smudged all bits below and including the highest set bit.
This isn't really a good example. It's not a good example. You should have other bits set. Alright, so whatever. This is like the common way to bit smudge whatever. So first you gotta do that. And the common way to get the whatever bit at the top after bit smudging is to like shift right to 1 and then XOR with the original. So if the number looked like this, whatever. If you do shift right 1, and you XOR that, all these bits get set off. Leaving the 1 bit, only the high bit. So now this bit, you use it if you want to get the bit this way, the position of it, without using a loop. It's also better to like use a table, a lookup table, or you can like store the bit masks. I think it's like 16 4-bit bit masks that you need. That fits in a 64-bit number. Maybe it fits, I don't know. I didn't go that far, I just put an array. It might fit. If it doesn't, you can always like expand it for like between 2-3 different numbers, whatever. However you do it, whatever. Well, that's not this part, that's this part. So you gotta bit smudge first to get the number like this. And then what you do to get the position of the highest bit set after doing these 2 operations. This is isolate highest bit. There's gonna be 1 bit that's on, only 1 bit. Like, I don't know, map. Map bit position as an ace value. Into, or assume does not work. I guess 2. So map isolated bit position to indice value. Or map from bit position to indiced. Whatever. Because it's gonna go from like the position of the bit to the indice of the bit, which is different than the position. So this needs to be the argument, not this random number. Put this here. And this can also be branchless. Branchless. I need some water, my mouth's dry. But I'm still talking anyways. Alright, so now there's no math involved. Only logic. So I'm gonna turn these masks into like the bit value of it, or the binary value. And then it'll literally, I don't know, it literally, you'll see. It's magic. And like, these two techniques are really commonly known, but I haven't seen anyone else doing this. So I like claimed this a couple weeks ago. I forgot to mark the video, but I did mark the video yesterday. So like, I don't know, I claim this technique. And this isn't the fastest, even if you make it branchless. It's slow, what the compiler makes. And when you write it by hand, it's a little bit faster. But using a lookup table seems to be like 20% faster-ish. But then I tested that in like a loop. It wasn't, you'd have to like actually test it like within like real code that's actually being run to get like a real world comparison, whatever, because like a tight loop, it's, I don't know, it has to be like tested in real code, whatever. I don't normally test for the highest bit position set, so I use it in a couple places anyways. Everything is based on context, whatever, and conditions and blah blah blah. So make this to the bit mask and binary. Each of these, so it's 1 1. Alright, so this is binary for the mask on the left. Now it's in binary. That was an hexadecimal. Alright, so you need these 4 masks to mask the isolated bit position to an index value. So my chat about to make like 7 random numbers, I guess. Let's do random. Instead of random. This is more random. Oh, I asked it to 255. It's not random when it gets bigger. Oh, it's freaking not typing. This is more random. That's not give me numbers. Like within 2-bit resolution of each other. Like they're all like, I don't know, 13, 14, 15 bits big. I just want to paste these numbers. and I'll get the highest. Oh, I gotta cover text test. I mean binary. Alright. Alright, so no math involved. Because math is for people who don't know how to pattern match. You literally don't even need math to do math. You just use brute force and logic. Because math sucks. And math is completely fucking pointless. Because it doesn't directly apply to anything in the real world. But with computers, straight up binary is on. It's what the computer runs on. Way more useful. Alright, so I'm gonna mask all these numbers. Pieces for all of them. There's no way nobody else thought of this technique. So I don't know, whatever. This is like the only one I'm gonna share. I'm not dumb enough to like share every single thing. Okay, I forgot to bit smudge. Alright, so I'm gonna like bit smudge a number. Man, this freaking... I zoom in, it just loses position. Basis in place. Alright, so highest bit's here. fill the rest in with 0. I mean 1, because I'm going to smudge a bit. Now I'm going to smudge it, I'm going to mask to like isolate it in this step up here. Where it says isolate the highest bit. So it's smudged, I'm going to sub 0. Next one. Highest bits here. Let's get all highest bits first. Highest bits here. It's here. Then here, I think 2 more numbers. Well, that's a waste of an example. There's like 2 at the same bit position. And the bit rate is dropping. I gotta check the stream. I think it's working. Alright, so I did this number. I'm gonna like bit smudges and then isolate the bit. Done. This number, it's done. There's nothing to the right of it. This number, bit smudge, or isolate. Bit smudge. Isolate. It's kind of like a narcissistic smear campaign. First you gotta bit smudge, then you gotta isolate, then you gotta hoover. It's like the same exact thing. You bit smudge, or bit smear, and then you isolate. They're terrible, terrible people. These are just bits. I wouldn't do that to a person. Some people do though. I don't judge, I don't care. It drives me crazy. Like, if someone's not already crazy to do something like that. But I said I don't judge, so I just say that as an observation. Because observation isn't technically judging, unless you come to a whatever. Alright, so there's no math involved. This bit here, I'm gonna do the mask here. If it's true that it's within the mask, I set a bit on. So I set a bit in the 8th position, 4th, 2nd, 1st. So the binary looks like this. No math involved. Testing the bit position, the column it's in, and it maps whatever directly to the indice position. No math, because math sucks. You don't need math. And we can pattern match, because you can pattern match to do what math does. And you can use lookup tables. At some point, you gotta use math. Alright, so because we're way too slow to pattern match and lookup table everything. So it's gonna mask whatever and keep the bit only if it's on. So basically, it's the same thing. I have all 4 masks here. Go like this, hit space. Now these 4 bits are magically the position of the highest bit set now as the indiced offset. Spaces here. I'll do this number. See, isn't this better than math? So no math involved. And then the next one. So if it's not obvious, is 0, 0, 0, 0. That means 0 in binary. So this is the 0th position, the 0th bit position. This is the second. I think there's 2 more after this. That's it. Alright, so here's the highest bit set. Now let's check out if this is the highest bit set for the numbers that it gave me. Whoever chatbot says, I'll just go by that. Unless it says I'm wrong, then I'm gonna be pissed because it's like, yeah. You fix it with Y. Why? I don't know. If someone decides to use Y to indicate when it's a binary number, because B is used for bits or a byte or so many other things. So why use Y to identify binary numbers? Why? I don't know. Alright, so let's chatbot. As you chatbot, is this the highest bit set in these numbers? Of those numbers in these numbers. In these numbers. Or the highest bit position. Is this the highest bit position of each of those numbers in these numbers. List them side by side. And chatbot says, dang it, I have to paste it. Why does it go to the mic? Oh my god, here we go. Wait, what? How? It's fucking... I guess chatbot just like disappeared. I also realized that I changed a couple of numbers. So, chatbot can suck a dick. I'll just fucking count it up. So this number 1, 2, 3, 4, 5. 1, 2, 3, 4 from top, so 15, 14, 13, 12. So 12. In binary is alright, so 12 in binary. Right here. 1 1 0 0. One one zero zero. Alright, so this 15, 14, 13. I think this is 8. So 1 0 0 0. If it's 8, then it means that it's 8. One 0 0 0. So 8. This one says 1 1 1 1. It's 15, so 15. And 15 is 1 1 1 1. This one is 1 0 1 2. Second bit. This is 2 in binary because it is what it mapped out to. Type in 2 0 0 1 0 0 0 1 0. This is 1 in binary. Well, it's 1, so it's in the 0th position. So it's bit 0. And it happens to be 0 here, so is it 0? Does it match? Yes, it does, because 0 0. Then this bit is That's 7. Or is it 8? Oh, that's 8. Alright, so if this is 8, that's 8. So 1, 0, 0. And oh, I forgot to flip it. This is getting really boring. Alright, last one. Alright, this is clearly 15. Because all the bits are saturated. That's 15. So this is like it's a 16-bit number. So I'll expand it to work with a 64-bit number. And I'm gonna get to finish up the shader. Alright, so it should be the same logic. Take this, copy it, paste it. So we need 2 more bits. That's it for. We bit smudge. Do you have to top the very test? Do you have to do the very top bit? Or only halfway? I'll just do like all the bit smudging. I don't feel like thinking right now. So 32. Same possible shift. 64 bits. It is in a higher level language. But you can't in lower level. Because 63 is this many bits. Then 64 is this many bits. Is this. In the modern, quote, modern CPU masks, like this. So when it masks a number that's bigger, it gets chopped off. If you do like 62 bits, it'll mask it, and the lower part will be kept. So it does do bigger, except it'll be clamped by masking it. But I think in higher level languages you can shift more. I'll like set it to 0. So in lower level though, you're always stuck to like, you can't always get that top bit without a extra shift. Only in lower level. Higher level, I don't know, whatever. Everything's based on context and conditional. So I don't know if I can. I'll just do this. It stays the same. But it might need to be casted to a long. I'm just gonna say this is not real code, it's whatever you call it. Not metacode. Whatever it's called. code that like represents code, but not actually code. Alright, so to mask it, it is going to be this mask. I can actually just put in the calculator. Okay, this part, whatever. I don't do like, not for this part. I get down to the end of it. Well, it might end up being the same. Alright, so I should need 6 different masks or whatever. Because there's 6 bit positions. 64. So each of the masks should be able to map to a bit. I really hope it does. If it doesn't, I'm gonna feel stupid. It won't be the first time. Definitely not the last. Let's see if I can pull this off or not. Totally an assumption that would work 64-bit. Because it should. Guess I'll find out. Alright, so this and then cut this in half. Cut in half again. See, isn't math fun? This isn't even math. Cut in half again. It's 1, 2, 3, 4, 5. Wow, it works. Good. Oh my god. Alright, it's gonna work. 3. Yeah, no, I don't want 3. I want C. Alright, it's gonna work. It's 1, 2, 3, 4, 5, 6. Alright, 64-bit numbers. Ta-da! So 16-bit. 64-bit. Dang, we do this again. Or just right up like this. 1, shift left. 0. A bigger number might have a bigger performance difference. I haven't tested yet. And I'm not going to test anytime soon. I got so much to do. Because I'm writing a JavaScript engine. And the 2024 edition, whatever. I'm going to go from page 816. I mean from page 1 to 816. And then every single section in the standard, check off every single box and every single page, mark it in the video description, and be the very first JavaScript engine to ever meet the standard 100%. The very first and last, because trillion-dollar companies can't even meet the standard. Not to lack of talent or money, because they're just stupid. Or I don't know. They can't do it. I don't know why. It makes no sense to say you have a JavaScript engine if you don't meet the standard 100%. You're not a JavaScript engine. It's black and white. There's no between. Well, there's gray. That's between black and white. But that's not a JavaScript engine. Let's go like, whatever. 0, 1, 2, 3. 0, 1, 2, 3, 5. Shift left 1 bit. So when the bit's set, it's the same thing as down here. So I'm going to take this and then modify it. I have to paste this up here. 64-bit number. Ta-da! Alright, so I'd assume it's gonna work out because it did expand correctly. So now I gotta find out if it does work. It should technically, theoretically. I did a fumble explaining it the day before. So, if I fumble, I fumble. Oh, I gotta make this a 64-bit number. So I guess I'll do that first. Ask chatbot to give me a random 64-bit number. I need some water. Oh, it's like stuck. Here we go. Make that hexadecimal or binary. Oh, it's sort of a 0B. That's weird. Usually it's Y. Whatever. Alright, so this is a random number. Oh my god. Alright, find the highest bit set. And then bit smudge, and then... Oh, it's... Alright, I'm gonna pretend it's not this bit, whatever this number is. I'll just bit smudge it. For how many bits? Carry the bit all for all of them. Carry the bit to the right for all the bit set. That's what it does in this part. With the or equals. And then isolatize bit, flip it, mask it, only top bit set. So all zeros. Ta-da! No math yet, or at all. Alright, so now we gotta like expand these. That's great. It's just fun. 32 Fs. $32. $16. Why did I copy that? It's basically just folding the number. Half and half and half and half. Eight. Four. Two, one. Well, that sucked. Not as much as your mom, though. Alright, so now, pivot position. Without even needing to use any math at all. Just fucking find the column. And then, that's it. Gather the rows. Copy. Paste. Move the spacing, or the new lines, or the carriage returns, whatever you want to call them. So this number is... Check the calculator. $111,011. I'll just type it like this. 59. This is octal. Okay, so I don't know. 59. So is that bit 59? Pretty sure it is. If it's not, I'm gonna look like a fucking idiot. So this is 57. I mean, 63. 63, 62, 61, 60, 59. The is bit 59. Ta-da! No math. Just patterns and logic. And I'll stop with the your mom jokes for now. I get some water. I'm gonna get back and I'll try to run the C program first. This make file. Yeah, no, there's still an error. That's cool. Oh, I need to like install this. I'm gonna get some water and then work on this. That's how to get the highest bit set in a number without shifting. I claim the technique. I'll have your be.
Valve is making